Well, it's Wednesday the 9th of June 2021 here in the goat shed. It's 10 degrees outside. It's officially winter here now in Australia. And today we thought we might do a short video on stepper adjustments and the names of some of their major parts. Now, the stepper is a very important unit in an electromechanical game, as it controls many things on the rivet disc, and the operation of these must be such that they work correctly. Generally, games that you've bought where the machine's never really been touched, the stepper hasn't probably been touched for probably 40 odd years or 50 years, the time the game's been, since the game's been made. Okay, so there are three types of steppers. There's a continuous, which is like a 0 to 9 unit stepper, just steps up and right round and keeps going. Then there's the resetting stepper. It steps all the way to the end, i.e. like this stepper here is a bonus stepper and it's a resetting stepper. And then there's a subtracting stepper where it steps back one at a time. So a good example of that is a replay unit. You've got 10 credits up and it just steps back one, and there's handled by a subtract pawl. Now, a subtract pawl isn't on this game, but if the subtract pawl was here, it would be here, fitted there, and it drops here into the teeth to check the movement on the escapement wheel. So we have this part here, which is the drive arm. This is a drive arm. Now that pivots on this pivot screw with the nut on the back. That's where they get really gummed up, and that's why they've got to come out. You've got to loosen the nut on the back first. When you reassemble that, a drop of oil on the shoulder of the screw is most useful. So that's called the drive arm. Then we have this here. This is the drive pawl. That unit there, that's the drive pawl, pointing to it. Bit hard to see. There it is. I'm operating the drive pawl. That's it there. This is the drive arm assembly. The drive arm, the drive pawl is attached to that, and this is the plunger with a coil stop, and this is this here is the drive arm stop there, and then we've got another up stop over here. Okay, so you've really got this position here. This is called the zero stop adjustment. So that's an arm with a peg on it, or not a peg, but the peg on the back. That peg right there, what I'm pointing to there, that is resting against the zero stop arm. Now, how we achieve adjustment on those is like this. The zero stop arm has to allow the reset arm to fall cleanly into a gear tooth. So what we'll do, we'll step this one up, and it's currently latched. This is a latch. So that's latched. When we release that latch, which by operating the drive arm, watch that latch is going to move now, and it's going to let this arm here move forward like that. Okay, that's pretty simple. That arm moved forward. Now, the whole idea of that's not touching there either. That, see that? There's a gap here. Right. Now the drive arm, or I should say the reset arm, when I pull that back, it has to fall cleanly into the tooth. Just like that. If it wasn't, that would mean I would have to adjust this screw here and move it in the appropriate direction. Now in this case, if that tooth wasn't high enough, I would have to loosen that screw and push the stop to the right, just to raise the tooth a little bit. But that's fine, that's going in and out. Now I hope you can see what we're talking about there. There it is there. Pushes back and moves in. Just like that. Perfect. Now the other adjustment is to get the drive pull. Once again, this is the drive pull here. There, to get the drive pull so that it drives. We operate the plunger, it drives, goes down, and it comes back up, and like that. We want that drive arm, as it gets back up to the rest position here, this limit stop here, the reset arm must fall into place cleanly. Up it goes, it's about to hit it now, and there's the reset arm going back in. Can we see that? Goes down, comes back up, there it is, it's going to touch that reset arm, and there it falls back in. Rarely do you have to adjust that, but it's adjusted by loosening these screws here, those two, but rarely do you have to adjust that. You can generally get an idea if someone's mucked around with it, because you'll see scrape marks on there. Now the only other adjustment that you have to do is the travel of that drive arm pull. So drive arm pull should go up, drop cleanly into the tooth, and only travel an extra half a tooth, and away it goes. So comes down, spring tension there, pulls it in, only want to go down. Now we're at the limit, we're holding that up as high as we can, and we're reasonably happy with that. It's going a little further than I'd like, but it's okay. The way to adjust that is to hold this in position like that, and you need to loosen the two screws on the back of that coil casing. They're located around the back, and move it up or down till you get the desired effect. Once you have that driving the way you want, you then have another adjustment to do, and that's this adjustment here. That's the drive arm up stop. Now, because the plunger here wears inside and the coil stop wears, eventually they ended up breaking right there pretty much, simply because the plunger is worn down a bit, the coil stop's worn down a bit, and it's over travelling. Now the idea, the whole concept of that drive arm up stop is to help arrest the movement of the plunger in under spring, or under inertia, I guess is the correct word. We don't want it belting against the coil stop inside the coil there. So what you do to adjust that, or what I like to do, is get a sheet of paper and put it between the drive arm and the stop, and just gently pull it apart. I'll just get a sheet of paper and illustrate that to you. Just a little bit of slither there, and we'll show you how we do that. 1 second. Okay, so put it in there like that. Whoop, got the air conditioner on. Put it in there like that. Hold it up. See that? That's between there and there. And then you can gently, it's going to be a bit hard, but you'll be able to pull that, and you just want to feel a little bit of drag on the way out. That's the correct way to adjust those. Now, the other thing that will happen when you put this back together, you'll turn this around. When this goes back on the machine, of course we're going to have lined this triangular piece up, and the rivet plate screws on, but when you put the rivet plate cover on, you really want it to be, well, that's the little part, I'll just get it for you. It's just over here. And you know, the cover. I should have had this organised. Here it is. You want this part here to be centered roughly like that. It doesn't go on like that or like that, because you've got no room for adjustment. So that's how you actually adjust the rivet plate to get it clean on the rivets. And of course this has to be in the right position, so you need to see where the screws were, where the Allen screws were on the shaft. They leave an indentation, and put it back roughly in the same spot to achieve that, so you can adjust it. And if you need any more adjustment, it's available. That's the reset arm, the reset coil on the neck there, just resets and latches. Now what I didn't mention was that the latch here, this latch, that's a spring-loaded lock. Right, I push that down out of the road and that allows it to fall back. When you reset the mechanism, it'll jump up into place like that. A spring-loaded lock is called a detent. Now, I don't think Gottlieb called it that, but that actually is the correct terminology. If you want to look that up, please do. But that's a spring-loaded lock. So that's about all we'll talk about on the stepper today. That one's been cleaned and refurbished. Got the sun coming through the window now, so it's probably time to sign off. So this has been another Goat Shed presentation.